as the Zoom user.
Oh, okay. Yeah. So Rich and I are in the same room, so we sometimes look across the desk into each other's eyes. I think really the thing that I'm really quite keen to, because we have huge amounts of what we call compost. You wouldn't call it compost, Daniel. So it's a mixture of cattle and poultry manure with some horsey litter put in there as well. Mm-hmm. And really what I'm trying to do is work out the best way. And I've probably got 1,000 tons of this stuff around the farm at the moment, and probably get an extra 500 to 600 tons of it every year. And I'm just trying to work out the best way on a large to spread the benefit across the 900 acres. Mm-hmm. Is to make sure that we're building that soil life on a really broad acre basis, and trying to adopt some of your principles. Yeah.
Have you been spreading that already?
What we have done in previous years, yes. Yeah. So, we see it every time. So we tend to use it rotationally at the moment. And we see a benefit well above the nutritional difference. So when we use it on a second winter wheat crop, for instance, we see a benefit, considerably higher than we do by having a second wheat that doesn't get this compost. And what we're trying to do, what we're working out this spring is how we can. I'm just waiting for the nutritional analysis to come back, is how we can apply a smaller amount across a larger area to replace artificial nitrogen.
So you're waiting for the regular chemical analysis.
I just want to get that, and then I'll probably ping it over to you to have a look at, because it's just going to be NP and K, but while we're transitioning from what I would term a traditional farming system, which is nothing traditional about it, traditional in the last 30 years, put it like that, chemical agriculture, while we're transitioning away from that, he's trying to work out the best way of doing it, really. That's the journey that we're on.
When you add synthetic fertilizers, right, in the normal system, it's usually pellets, right?
Yeah.
And some farmers are moving towards sprays for efficiency, right? Where is that move coming from? Is it because of the pellets sort of sitting on the ground, and then some of the material simply goes through the soil, never reaches the roots? I mean, how does that work?
Yeah, I mean, for me, it's about efficiency and cost. We know that when we apply, and also preserving our organic matter.
But explain to me basically how the normal system works.
Okay, so
if you have the pellets basically, and you spread the pellets, what is the efficiency of actual take-up of the nutrient from the pellets?
Barely 60%.
Barely 60%.
Yeah.
And this is something that you've seen with other farmers, or is it just your experience? How do you judge that?
Well, we've done our best to quantify it. Mm-hmm. I think that most farmers would be in a very similar position. I think we probably get pretty good efficiency because we put on little and often rather than, great big, some farmers put on massive dollops, mm-hmm. simply just so that they only have to do it 2 or 3 times. Whereas we go through 5 or 6 times, little and often, to sort of teaspoon feed the crop. But we're trying to get away from that. I mean, we've been reducing the more compost we've used, we've been reducing the total amount year on year for the last 5 or 6 years now, and haven't seen a yield decrease.
How much have you decreased by an off chance?
Well, I mean, we were putting horrendous. This is I was a nitrogen addict, but my name is Doug Wanstall. I was a nitrogen addict. Yeah. We were putting on some high yielding millie wheats. We were putting on 300 kilos a hectare of N. Well, 300 kilos of nitrogen. We're now down to about 180.
180. That's about 40% reduction now.
Yeah. And
how much of your compost have you been putting out there on a yearly basis per hectare?
Varying amounts. We're getting a bit more sophisticated about it all now. But now we're looking to apply the compost in the spring rather than because it's quite high in nitrogen, our compost. I'll know for sure when I get the results back this year.
Because it's manure based, is it?
It is manure based, yeah. We're going to apply that in the spring and probably only top up with granular nitrogen if we feel that through bricks testing that we need any more.
So you've managed to reduce about 40% without yield loss. What sort of average yields on milling wheat are you getting?
On winter wheat, last year was a poor year. Last harvest, the 2021 harvest was quite poor. We've averaged probably, we don't know yet, but just below 8 tonne a hectare.
About 8 tonne.
In a good year, we would be near a 9.5 to 10 tonne a hectare average.
Mm-hmm. Give me something to aim for.
Sorry?
You're giving me something to aim for, basically.
Oh, okay, yeah.
This thing about sort of managing the resources that are on farm and maybe some of the off farm as well. It's something that's that I think a lot about. Do you have a turner, by the way, for your compost, or do you do it all with a front loader?
We do it all with a loader at the moment.
Okay.
A farm loader. I mean, funny enough, I'm waiting for a quote for a turner because I can see we can potentially get quite a lot of wood chip, and I really like the idea of being able to incorporate the wood chip into what we're doing. Whether we compost the wood chip first to get the fungal activity up in that, and then mix it with our current compost or not, I don't know. But that's where I probably need some pointers.
Wood chip will take a while to break down. But obviously it's a good addition. Anything carbon based, if you add to it, obviously increases your fungal activity there, but it takes more time as well. Okay, so that's interesting. You don't remember how much you've been putting out per hectare of your compost?
Well, it's been between 12 and 16 tonnes a hectare. But we're looking to apply quite a bit less than that this year in the spring, but spread it across a far greater area. So between 5 and 7 tonnes a hectare, if we can do it accurately. We've got a new machine. Well, we haven't. The contractor's got a new machine, and we're hoping to be able to.
Is this a regular back spreader?
No, it's not. It's got a hood and spinning disc, so it will spread accurately over 24 meters.
Mm-hmm. So then, basically, that's composted manure with the bedding. Bit of chicken manure added to that as well. Do you sieve? Do you basically grade your particle size before you spread?
No.
Everything goes. And so you're going to be spreading this in spring onto the growing crop already.
Yeah.
You don't see any problem with that. That's all fine. That's been working fine for you.
Yeah, I mean we've done it before. You have to be a little less farmery and ignore the fact that you get a few extra wheel marks, but actually the dividends are significant.
Mm-hmm. No, it does sound like it, especially with the current, synthetic fertilizer prices.
Yeah.
I'm curious basically what they come back with in terms of the nutrition. 5 to 7 tons a hectare. obviously we're working with something like 70 liters a hectare, so
Yeah.
we're at a bit of a disadvantage in
Yeah.
terms of application, right? So we just have to work with the microbes. So it's going to be it's interesting, what could be done if we add the microbes, because I'm interested also in the concept of resource efficiency. See what we can do actually in that regard.
Yeah.
I have been sort of trawling through papers, and I've not had a chance to read them from start to finish, but I've been sort of browsing through them, and everything sort of points towards what Dr. Ingham talks about fungi. That if we have more fungi, they're better at using those resources. They could be also better at hoarding the resources. So that's something to look at. But in terms of actually using the resources and keeping them from going anywhere, they're better than bacteria.
Yeah. Will it work if we create a if we create a high fungal activity, a high fungal count wood chip compost? If we make a specific small amount, make a compost tea out of that seeding material, and then spray it on our compost that we go and then spread on the fields, what are our chances of increasing the fungal activity in the larger piles of compost? Did that make sense?
Yeah, I mean, if you manage to get, obviously once you get good numbers of fungi in your smaller piles, you can sort of do an extract and put that into your larger piles, and they can take to it. You have to sort of consider the time factor as well. It might be the case like Dr. Johnson kind of you wait for a year before you get some results in that matter. In terms of the wood chip, consider actually finding something relatively fine as well to mix in, because we're just sort of thinking we have started experimenting with sort of smaller particle size as well. The more surface area, the bigger the chance that you're going to have a faster growth on it. Mixing that with manure, obviously manure, the nitrogen manure is going to help the fungi grow. This is what they talk about, so the nitrogen robbing by wood chips, because it's fungi also need nitrogen to grow. So it's like this first part of this whole development that they're going to be using that. So maybe experiment with some smaller quantities, maybe make some smaller piles where you just basically maybe make even some Johnson soup piles for them to be just sitting there and waiting for once it's done. We're actually considering another product which is experimental, but it could help with growing fungi in a pile like that. So you might get to it at some point. I just need to sit down and sort of work out all the costs and see what I can do with that. But it could be helpful. It wouldn't be too expensive actually.
Yeah.
So that's something to consider, because we'll be experimenting with that too. Yeah, big subject.
Yeah, yeah.
The thing is with the you mentioned about compost tea brewing, and it's probably best to just avoid that because we don't see any significant growth in fungi in a compost tea. We probably advise you just make an extract and apply that straight to the target that you want to increase the fungi in, and not bother with the bubbling process or the feeding.
Oh, okay.
Compost teas are more kind of aimed at boosting your protozoa numbers.
Yeah, that's a good point. The one thing actually about teas as well, I was reading some stuff the other day. This is actually just a reminder of what Dr. Ingham wrote I don't know, 20 years back now. If you are doing compost teas for protecting your crop from fungal infections, from mold infections, they are effective when you've got like a 5% fungal component in them. So you basically are, you're doing a tea mixing with the extract kind of thing. And when you have that fungal component, about 5% fungal component in your tea, it's got the highest suppression value for I think they were experimenting with Pythium or Fusarium. I can't remember which one that was. I would need to reread that again, put it in my skull. But that's on a side note.
Yeah.
But yeah, it's interesting, you know, going back to your original problem. It's interesting, you know, once you get those results, it will be interesting to see, obviously, the sort of resource efficiency.
I don't know whether biochar would actually affect that.
Yeah, where do you see biochar fitting into any of this equation, or is it something that is a totally different subject and, you know, not kind of part relevant to this whole compost, you know, soil biology diversity conversation?
I've not put enough energy into biochar, but I have come across papers, and obviously there's lots of interest these days. You know, it's been recognized as a tool for fighting climate change. If you know, if this is something that interests you, so there's going to be lots and lots of people burning wood, you know, to get this this product. Micronized biochar is something that would work best with microbes, so it needs to be pulverized. From what I understand, Mr. Mitchell joined us today. That's the mysterious Zoom user. He's muted.
Apologies for that. I was cycling home, and so yeah, couldn't answer at the time. But I'm home now, so I can turn on the video. How is everyone?
So yeah, very good. Thank you. I'm just going to finish with this biochar thing.
Go for it.
I have seen basically papers, but again, I've just skimmed through that stuff. So if you want to ask me for a proper answer, I would need to go back and read them. But there is, you know, like the basic function, it would be sort of, you know, providing apartments for bacteria. They can then develop inside the little pore spaces, and then, you know, once they start flowing out from these pore spaces, protozoa can munch on them, and it's like a extra way for allowing the bacteria to develop safely before they get all munched up. I believe there would be I don't know, somebody else will need to correct me, but you know, more sites, more extra sites for cation exchange. And lastly, and this is something I've seen one paper about, because I was looking at the lowest temperature for breaking up lignin. And so lignin, just like any polymer, basically will start breaking up at a certain temperature. And so during pyrolysis, you know, this is what's going to be happening to lignin. And so if you're breaking up lignin due to higher temperatures, you're creating, you know, simpler substances that are easier to be picked up by some other, that could be easier to pick up by some, you know, more like larger group of microbes, maybe as a carbon resource. However, biochar realistically is just really more of a mineral carbon than a food resource. So these are the only things I can think of right now. Again, there probably are some specialists out there that would have a better answer, but there are papers out there about biochars and microbes.
That's great. Thank you for that. You can get onto your subject now, Daniel, instead of me hijacking it.
I'm going to actually allow Glyn to hijack at some point if he wants.
I don't think I've really got anything to hijack. Hi, everyone. Yeah, just my experience on biochar. One thing you didn't mention there, Daniel, was the food stocks for the biochar is really important. And we've seen some really different results from feed, you know, putting the feedstocks or biochar in the feedstocks. So we had quite good success with biocharing some of the food waste coming from the aerobic digester. But some of the softwoods we used, we didn't have some very good results. So again, feedstocks, a lot more work needs to be done on this area, but it's interesting and it's developing.
And how did the results vary then? I mean, how do you define not good results from softwood?
It was really Yeah, the decomposition, I think it was, the nutrient availability. So we saw some results in the hemp that was quite significant with some of the food waste resources that we were using in the biochar, which we didn't see the same growth potential in some of the softwoods that we were using to biochar. So, to be honest, Doug, I didn't do enough experimentation on the specific types of softwood that we were using. Because I just asked the tree surgeon to deliver some softwood for the experiment, but there was definitely a difference between the pelletized food waste that we managed to biochar and the softwoods. But more work needs to be done on it. Like everything, it's only a learning curve. It might have been the case with hemp, but I don't know whether that's going to be similar with wheat. One of the things that crossed my mind in one of the conversation you were having earlier, about the composting that you've got on your farm, which sounds fantastic, is one thing to keep into consideration is the other microbes, not just the fungi that you're going to go for. You really want to start looking for the protozoa, and particularly the nematodes, to make the nitrogen that's retained in the bacteria available. So if you're going really just chomping off for the fungi and really not taking consideration of the protozoa or the nematodes, that is what we're finding is a major handicap as well. So I made a very fungal compost. But I didn't get the impacts in growth. And I think Daniel and I have spoken about this in the past, I think it was Tanya actually, where we had a really good, fungal dominant compost which was added, but we didn't get the impacts coming through in the growth potential. There are a number of reasons for that, but one of them is if you haven't got the higher level organisms actually liberating the nitrogen in the bacteria and making it available to the plants, then of course that will create a bit of a headache as well. It's playing with biology is always it's never straightforward, Doug.
No, but hopefully my microscope's going to pitch up any day now, so I'll be able to start seeing what is in there. Yeah. Well, mind you, got to learn how to use it first. So.
Well, Daniel's good at that.
Yeah.
I don't think there's anything else, is there, Daniel, you wanted me to add? If I missed anything, I was on my bike, so if I missed something, I apologize when I was riding.
Nope, unless there's anything you wanted to pitch in, but that's fine.
Not really. Doug, were you in Jersey the other day?
I was. I had a whistle-stop tour yesterday.
I knew you were coming over somewhere along the line.
No, but there's no secrets on Jersey, is there?
What it was?
Yeah, yeah. No, it was a whistle-stop tour. I was there literally for the day. Left home at 4 o'clock and got home at 10:30. So 4 a.m.
Oh, I'm sorry you didn't drop up to Warwick Farms. Come and have a look.
Well, I think I'll be coming again fairly soon, so I'll make sure that we fit in a visit to you next time.
Oh, that'd be fantastic. I look forward to that.
Yeah.
Cool. Well, I knew you were coming over around this time, but I wasn't sure whether you had been or not. So, yeah. Next time, definitely, it'll be good to catch up. Sorry. Moving the subject aside, Daniel, we're kidnapping your room here.
I'm quite happy about, kidnapping. Sorry that didn't come out right. But it's fun basically that we can basically just meet and have a chat. So this is what I like about these meetups as well. And sometimes there's good technical questions, and then basically we have a good conversation on that. So I'm curious what you're going to get in terms of your trainer once you get that. I think there's a couple of people that have participated in this group in the past that would be able to advise on that too, because obviously we don't use a trainer here yet.
So Daniel, I've got a question that came up. The Oxford Real Farming Conference thing came through today. I don't know if everyone's seen it. The online event pushed out, and the event that you're doing, is it that the Soil Food Web one with the New Zealanders?
Yes.
Oh, okay. Yeah. Well, they've got the title up there, so that'll be interesting. That'll be cool.
Where did you see that? Because I don't know if I've even seen that.
So that came through. It was an email that came through from the Oxford Reel today, because the online applications have actually been have just gone to press, basically, I think, and they gave a list of all the what I don't know whether there's if because they said there was something like 40. It was going to be available for about 40 of the presentations, but then they said there was extra for the online lot.
So yeah, this is something that we've been invited to chat alongside the people in New Zealand, and Dr. Ingham's going to be there as well. So we're going to have a little session. Don't know exactly what we're going to be talking about, but probably some microbes. Seed dressings. Well, do you know what, Phil? Actually, in terms of seed dressing, this is still an open question. Is it just biology as per compost? I mean, I'm not sure how to understand that question, but we obviously take biology from the compost. If you're thinking of sort of ratios, what goes into the seed dressings, my aim was always to concentrate as much as I can onto the seed, so that there's as much as possible during the application. But then there's people like Tommy in Ireland who's got a little drip feed going onto the seeds before they get loaded into the hopper, and for him that's enough when he's inoculating his seeds. So I'm really not sure yet what is what's going to be the best sort of application rate and the best method, how we're going to deal with it. There's a constant problem with and there's also, I think Andy Howard, he's got the mycorrhizal inoculant is worth looking at, Phil. Yes. Going back to yes, Andy Howard, basically he's got obviously the tractor with the tank in the front and extra piping going behind the drill, so that he can inject directly into the soil when the seed is being planted. Now, in terms of the mycorrhizal inoculation, yes, it's worth looking into. Compost will not produce your mycorrhizal propagules. So we would like to actually be producing our own mycorrhizal propagules here, but we haven't started experimenting with that yet. It's something for next year. How do you choose mycorrhizal inoculant? Endo, ecto, AMF. So endo and ecto and AMF. So MF is mycorrhizal fungi, AMF is arbuscular mycorrhizal fungi, and most of the arbuscular mycorrhizal fungi are endo. It's inside, it's endo mycorrhizal fungi. So endo and ecto just basically means that it's either inside the root or outside the root. And I think I've got some pictures actually of if I find it, but basically the rule of the thumb is the ectomycorrhizal fungi, the ones that live on the outside of the roots, they're on trees. So majority of the stuff that you will find in bug in a jug format for your cereals or for your pastures, that's the AMF fungi. That's the stuff that produce arbuscules inside the root. So that's what you're aiming for. In terms of the ectomycorrhizal fungi, I actually don't know of any products. I haven't looked hard enough. I know that if I wanted to do something like that, I would go to the forest probably and start looking at transplanting that. But I haven't seen products per se. There are probably some out there, but it's very niche because it's very sort of geared towards tree roots. So that's your mycorrhizal fungi, and yeah, you're definitely you'd be very good to experiment with that. The thing that we want to measure with Sheffield University, the reason, for instance, we want to go with DNA analysis is we don't know yet if we have, for instance, some of the known microbes, like some of the nitrogen fixing free living microbes in our compost. So that's something that we would like to confirm if we have that in good quantities. And if we don't, then we'll be looking at ways to grow them out. Then there's things like was it phosphorus mobilization or phosphorus solubilization? Then there's potassium mobilization bacteria. So there's a number of microbes that do a number of different jobs, and we don't know if we have them, and we'd like to have them. So the one things that we can tell that we do have is obviously the protozoa, the nematodes, things that we can distinguish. And as the Zoom user said, we need to focus on those higher level graziers to make sure that everything that these bacteria produce do that. So then we want to have in the system, in the soil, we want to have everything. We want to have the free living bacteria. We want to have, if you're growing legumes, you want to have the rhizobiums. If there are endophytes, we want to have them too. If you've got mycorrhizal fungi, we want to have those. The free living fungi, the ones that we grow out, we want to have those too. So we want to have everything. And then we want on top of that, we want to have the nematodes and the protozoa. And only then, once we have, the whole thing, then we can answer finally the question, does the soil food web allow us to grow a crop at 8 to 9.5 tons of milling wheat grade without any further inputs? So that's basically the aim for everything we do.
So one thing that you, which is quite interesting, where Doug will be benefiting from, I think you mentioned you got chicken manure in your compost, haven't you, Doug? Yeah, it's the boron element, and this is the biggie that we find, and this is where I don't know how chickens magically brew up boron in their poo, but they do. So getting that into the system is really important, and we find, but you've got to be very careful on obviously the temperatures when you're starting putting in that high nitrogen mixture into your compost, and not too much. But we always include an organic chicken manure into our composts. And Daniel, just one thing is when we did the analysis of the mycorrhiza spores from some of the products you can actually purchase now, we're finding that there are only about 3 or 4 spores in them. But out of our compost, we were hitting about 7 or 8. So again, it's trying to find out resources. So we do use root material in our compost. Whether that helps in getting the spores into it, I don't know. But it is possible to incorporate.
I was thinking of that too, actually, because a lot of the material that we get, for instance, here comes from landscapers, and so they don't include any roots, and so we wouldn't be getting naturally stuff. And this is something that I was considering as well. And the one easiest thing that people can try and do, obviously, and this is what we're going to try and do too next year, is to grow a target crop in compost, mature compost. That and you find propagules, or you buy propagules and include that in there. And then there's a matter of monitoring whether the propagules actually take to the roots. So that's something that we want to do, but it's obviously an involved process. So in terms of the products, I've seen products as well where the number of propagules per square meter and the applied rate is less than the seeds in the square meter that you're applying. So it's a bit of a challenge then for the propagules to meet the seeds and actually start growing into the roots. So it is something to look into. Dr. Ingham actually talks about, if you do have a mycorrhizal product, actually put them into, this is something that I haven't tried yet, but actually put them into a compost tea when you're brewing it. And some of the little amount of sugar that you would put into the compost tea should allow them to wake up. And so if you're doing this in conjunction with drilling, the theory is that the woken up propagules would then be there when the plants start rooting as well, kind of thing. So that's something to think about. Maybe actually not in the drilling.
So just to clarify on that, if you put it into at the beginning of the compost tea making, we found it wasn't so effective. But if you actually just add it after the completion of the compost tea, just as it's going into the tank before the drilling, that's where we got the most impact. So
you don't need much time then.
You don't need, sorry?
They don't need much time then.
They don't need much time at all. So you do your compost tea brew until you get what you want. And then literally at application, you're adding in your spores or whatever where you're going for your whatever it is you're going for.
Thank you. That's very helpful.
Especially on the golf courses. When we were treating the golf courses, we found that was really effective way of getting rid of Fusarium and some of the especially the fairy rings. It was really effective on that.
That's interesting.
All good stuff.
Armin, thank you for there's another question. A lot of American seeders are gravity fed. Most UK drills are air seeders. Very much. Does the air blowing the seed at hard surface affect the biology? Good question. I mean, it depends if you've got the biology on the seed or if it's sort of being applied behind it, drip fed. Any sort of impact obviously can reduce the number of microbes. So that is something to keep in mind.
I'll come in on the air seeder for a bit. We've tried the air seeders and trying to put the biology in with the air seeders, and we've just had disasters. Whether it just blocks it up or anything like that, it's really, really difficult to get to get the coatings in with the air seeders. But using it as a drill and probably putting actually some sort of device where you can drip in around the seed is the most effective in our experience.
Yeah, it seems that that this is sort of where it will be going, because my understanding is that we get the best results with these microbes in moisture, living microbes. The moment we if we have a seed dressing, then there are problems with clogging, and we've experienced clogging of the drills as well here. And so then there's a case of, okay, well, maybe we can dry the seeds beforehand, but then we lose a lot of microbes, especially the protozoa. They will not survive that.
And this is a biggie, and I think we've got it's one of the things that Elaine has actually hammered on quite a lot is you've got to always have two lots, a minimum of 2 lots of different types of microbes to actually affect the nitrogen cycling or nutrient cycling. So if you're only putting in bacteria and fungi because you're drying it and they're the only ones that probably survive, maybe a few nematodes, but you're missing out on the nutrient cyclers, the protozoa and things, then you are going to get a much less impact from those applications. So I'm a great believer in actually applying microbes in some sort of liquid just to try and increase the numbers and the diversities as much as possible.
Yeah, this is where I sort of looked into even going at what's it called now? Is it silage tanker with a dribble bar? Something that you could take, like a compost slurry almost thing. If you have a lot of compost, you might even have just your regular compost, but then have some sort of an addition with just the microbes. Slurry tanker with dribble bar. Thank you, Phil. If you basically even have normal compost and something that that is roughly extracted, maybe, or if the slurry tanker obviously can take the larger chunks even better, but then have the biology from maybe a better compost batch that you had somewhere else extracted, mixed into that. And then basically what you get is the microbes, the target microbes basically have a lot of habitat when they land on the soil, because then they have the moisture and the food resources, so they have space to hide in, and it's not going to be a hostile territory for them to go into. So it is something that it's one of the biggest problems for us to solve, I think, is survivability.
So the one that we're playing with at the moment, which seems to be having quite a good impact, is using some of the worm compost. We're getting a much more better uptake with the protozoa through the worm compost, through a good fungal worm compost than we were just through. I don't know whether it's the stickiness, the glomalin impact, or the glomalin content of the worm compost that is actually able to support the moisture that the protozoa need. But spreading a good worm compost after, at sowing, just after sowing, we're seeing quite a good uptake of the biology in the soil as well. So that's something we're playing with at the moment.
How important is epigenetics? I am keen to save seed to try to make the most of epigenetics. Is this a good plan? Can somebody enlighten me what epigenetics is?
Epigenetics is how the environment affects the genetics. So how the genetics respond to the environment. He's talking about over multiple generations, I guess, saving seed, and how it's going to affect how those genetics express.
So basically the genes switching on or off depending on the environment.
He agrees.
He agrees. I am keen to save seed to try to make the most of epigenetics. Is that a good plan? Well,
can I come in on this one?
Yeah, I mean, yes, please. I would say obviously you're going to become a plant breeder, but go for it. Yes, would be used to local environment. Go for it.
So I think where we're seeing a little bit of interest on this one is that how the seeds, natural seeds, heritage seeds particularly, are very adapted to, the microbial diversities in the soils. The big problem that we're having at the moment, and we spoke about this to Daniel and Tanya the other day, is how, the seeds have been altered genetically, through whatever systems they're using, synthetic systems of altering the gene of the seed, particularly with maize. And we're finding that certain, potatoes are another one. They've actually just lost that connection they have with the microbiology. And when you put them in a very microbiological soils, they just don't, they don't react at all. And we've seen quite a lot of this. And this is, and when we've actually tried it up against the hemp, because hemp and maize, for example, are quite close in their, in their growth rates and things like that. We've seen hemp, which hasn't been messed around with so much, take off, whereas we've seen maize, which has just taken off the shelf, not take at all. But when we've used more of a heritage seed maize, the colourful type, then we've seen it match the hemp. So that's quite an interesting area that needs a little bit more looking at, I think.
Yeah, this is something that will be useful to do on a small trial basis. Maybe just because we have seen an example of biology being what Glyn is referring to is we've seen an example, not in the UK, of biology being used to grow maize. That was normal maize, something that was used by the farmer previously in the chemical system. And they've done everything right. They've put a varied, there was 5 species of in the cover crop. And the maize was planted into the cover crop. And the cover crop grew after being cut a couple of times, but maize didn't. And some patches grew and they never actually produced any cobs. And so this is something that we would like to see an experiment on. So if you're looking at taking some heritage maize, well, I have been finding it difficult to get heritage varieties commercially. I don't have any sources yet. So if anybody finds sources of oats, if you this is the problem with with grains in particular. I did say early on that this is DEFRA statistics. Only 0.6% of all grain production in the UK is organic. So finding heritage stuff may be difficult, but this is maybe something, if you're interested, a longer term thing might, of growing your own, trying to breed your own things, maybe worthwhile. But we also have Darmit on the call, and Darmit is in Scotland, and he's an organic farmer and has been for years. Maybe Darmit could answer the question of getting some heritage varieties, especially if you're after oats. If you can hear me. You're not listening. He's switched off. He's busy.
Could it be as well that the conventional techniques used to cultivate the seed are not allowing the mother plants to load endophytes into the seeds and tubers? Rather than them, because it feels weird to say that they've lost all link to microbes after, millions of years of evolution in a single century. Maybe it's just that the mother plants aren't imbuing those endophytes because they're in such a sterile environment. What do you think of that, Glenn?
Yeah, it's a really interesting one. This so we're actually getting some seed. Well, we're working with one of the big institutions in the UK to get some UK Pacific seeds. And one of the questions that I sent off to them as part of the program is what are they growing the seeds in? Is it going to be what is it a fungal bacteria? What is the fungal bacteria ratios that they're growing the seeds in? And they're growing them in a very, very bacterial soil. So they're in effect, looking at these seeds and working their magic somehow, whatever they're doing. It's a bit witchcraft to me, to be honest, to how they do it. But if they're growing it, if they're developing these new seed strains in bacterial dominant soils and not in the succession that the crops prefer, then naturally they're going to be selecting for that type of soil, if you see what I mean. And when you try and get when you purchase that seed on a commercial system and try and get it into, say, a better successional soil, it makes life a lot more difficult. So it's a really difficult one, but until the research centers that are actually developing some of these new genetics and seeds are actually looking at the biology to grow the seeds in the first place, I think we're up against, again, another problem in the long run.
Yeah, it's like Professor Wolf used to, just focus on his multiple species wheat varieties, and it seems that there's quite a few examples around the world where people would breed their own varieties, that would be very well suited to their region and their soil, actually. But it takes quite a long time as well to do that.
There is definitely scope for some more seed saving, particularly on farms. And I would recommend, particularly in the organic sector, is to start, just keeping back some of the seed from your previous crop to keep developing. We've been doing that on a personal scale on our little farm for years and years and years, and we haven't actually purchased any seed for probably 10, 15 years. And every year it just seems that the crops are just getting better and better and better. So they're growing with the succession, which is what you would expect. So as the microbial successions develop, becoming more fungal as the plant successions, for trees and things, we're just seeing so much better resilience to pest and disease by working the two together.
And on the point that you said, Adam, as well, I recall John from Union Bioscience talking about how the endophytes that he sells, for what is it? He's got them for wheat, doesn't he? He would basically have wheat that doesn't have any endophytes, put them in with the crop, and then the next year, basically, the seed that comes from the mother plant basically now has the endophytes, and so if you do save those seeds, then you don't have to use his product anymore, because now we've got those seeds saved and the endophytes are in it. So there's a lot to say about saving seed, and obviously in the current paradigm, where there's lots to talk about, the varieties that are being sold, like use this variety because we've got these traits bred in, whatever, and everybody is just simply buying the stuff that's on the shelf because it's being promised as the holy grail. but it might be actually the seed saving that will allow us to rebuild a lot of these stocks of microbes.
Because in that sense, it could be the same as colostrum for cows, or associated problems with cesarean section babies. Just the first moments of life, not getting in contact with those endophytes could be really detrimental.
Yeah, I mean, you mentioned their babies. It's like infants. That went through a cesarean section. Don't have the same biome as the ones that were born naturally, and then infants who don't get fed mother's milk have got a problem actually building up their microflora in the gut. There's a lot to say about this stuff in terms of what gets inoculated and sort of lasts throughout many years. So yes, in terms of multiple varieties mixed together, Phil, as long as they ripen at the same time, yes, you're right. This is a big sort of problem. What's it called? Wakelength population weight. Well, in terms of the ripening together, because the suggestion is, I think, Phil, this is building on what Professor Wolf was working on. So he had the mixed varieties sward, didn't he? And so this is something that is important for many farmers, that they all ripen at the same time. Otherwise, we're going to go back to a situation where people have lots and lots of wheat varieties because they're ecological, and then they're going to terminate it with glyphosate because they won't be able to get in the weather window. So.
The Wakelands population wheat is 20 different varieties.
Wowzers.
And this was just explained to me, a wheat trial, which was an organic wheat trial. And they weren't talking directly about it, but the guy said it was very interesting because if you take 20 old varieties, the only one I recognized was Claire, but that's because I'm not that old. And you crossbreed them, you get 200 different crossbreeds, and you plant that, and it will organize itself into the most successful one for your area. And I was happy with that. I thought that was genius in itself. But then the guy said, keep your seed and plant it again and again. And all these different crossbreeds will eventually organize themselves into what adapts for your farm. So it was good fun because I was at a seed sales farm, and they weren't going to make any money from me once I bought their seed. But the theory was nice and sound. So you're
taking the hybrid to F1 and then F2, F3, F4, yep. F5 up to F10, and then at that point it's kind of a stable line for your environment.
Yeah. And because the end user is chickens, I don't really need to worry. I'll get it sampled every year. I'll have a relatively flat profile of protein in it, and I'm not that bothered. It might not work if I was selling it for bread, but I don't need to care about that at the minute.
But we'll see if it grows all over the place anyway.
Yeah, exactly.
And going back to the previous question that Phil had, Darmy, do you have any tips for him how to get some of that more heritage stuff for oats?
No, it's a complete nightmare to try and get anything old because nobody has it, nobody grows it, nobody cares about it. Everybody cares about yield. They don't care about disease. So that's as close as I've got. That's the first time I've heard anybody speaking about it. And it was obviously the professor fellow you were talking about. He pioneered it. So I was happy enough. I had to work reasonably hard to just get a bag up here into Scotland. But no, for the rest of it, it's a case of whatever's on the market that I can buy organically will buy. And if I can't get it organically, I will buy it conventionally and get a derogation for it. In the case of hemp seed, lupin seed, pea seed, all of these things that I grow that nobody makes organically. So we're miles away from worrying about organic crops, heritage crops, I should say, because, conventionally it's hard enough to get organic crops. So, yeah, we'd have to go back in time for that.
Great. I haven't got any plans for a time machine. Sorry.
Right. Okay. Well, then it's interesting talking about compost, because nobody knows how to make compost anymore, apart from Mr. Zoom user, I would suggest. And we have to go back in time where everybody knew how to make compost. So it's a bit of a farcical situation we find ourselves in, doing research on something that they already knew how to do.
I came across a book from 1955 about sort of commercial compost making from America. 1955, where people were talking about that.
Albert Howard, 1936.
Yeah, I mean, I know that, but Albert Howard, I mean, he was doing his stuff obviously in India, but we're talking about the Western world. And the guy who published that book, in the preface, he writes that this is a culmination of 30 years of work.
Yeah. Okay. Yeah.
Yeah, but Albert Howard, and actually my grandfather was sent out to the colonies to experiment with organic farming, where they kept the chemical stuff within the UK. So the documents are all there within the UK of all this organic farming practices going back a long, long time. And we had Lady Balfour, who was actually based here in Jersey, doing quite a lot of the work. She had a project in the UK, which I think is still going, where it's been proven, but the problem is it's just all been suppressed for a long time. Going back to the heritage seeds things, there is more and more heritage seeds coming online, and I think the best place to find out more about them is at places like the Oxford Reel, where people are talking about, any seeds that are out there. I know, Van Dam Shaba talks a lot about this heritage seed aspect, and I do encourage anyone who's developing or keeping their own seeds, and I highly suggest they do, and just think ahead for the next year. We do. I'm growing 12 species of cover crop seeds specifically just to try and create sort of like a heritage seed. So I bought in some organic, or what I thought were organic, the best organic I could. And we always collect some seeds just literally for the following year. And it's amazing the amount of seeds you can get from quite a small crop. But if you dedicate one field just for your own heritage seeds, then I think that's probably the best way. And you just select the best ones and create your own genetics.
I'll just have to start a new branch of the business. Just be a grain merchant for heritage seeds. We'll be building that bank.
Seed co-op might have some leads.
Yeah, but seed co-op is more of a sort of a small scale. This is the
I said leads. I didn't say grains.
But if this is where there's a great need is when you do get that fantastic microbial bridge between the seed, the seed succession you want to grow, and the microbial bridge. It's definitely worth protecting that seed, because you're taking it back to its heritage status, and that's becoming more and more difficult to find.
Yeah, it's the stuff about endophytes. This is something that Adam was talking quite a lot a couple of months ago, especially. We know, for instance, that there are fungal spores inside leaves that are dormant until the leaf actually falls to the ground, and autumn happens, and then they wake up and suddenly grow through the leaf material. So it's basically there. All the trees that have been there for decades, they've got everything inside them already. But if we're working with a synthetic system, which basically is sterilizing the whole plant, they never can actually establish inside the plant and actually then pass on that bank of microbes to the next generation. So the stuff about saving seeds it's going to be a big one. And you could probably have a presentation just on that for the Oxford Real Farming Conference if you've got an idea for that. Cool. We ran over, but we've managed to squeeze some good subjects into this one. I really appreciate you being here today. So thank you very much for everybody's participation today. Darmy, do you mind if I introduce you to Phil over email?
Yes, that'd be terrific. Thank you.
Okay, you're both up in Scotland.
And sorry, is Zoom user Phil or is Phil?
No, Zoom user is Glyn. Phil is Phil.
So Zoom user, for me, I've just been only online for the last 15 minutes. Sounds like a hero that I need to speak to.
You're very welcome to, and we are hemp growers as well. So I think we've got something similar. I'm growing hemp down in Jersey in the Channel Islands.
Who are you growing for?
Jersey hemp.
All right. Okay. Yeah. No, I'm with Bristol Hemp, but all of that's good because our hemp, this is all my interest in compost came from the fact that my hemp didn't grow in the field in the 5-acre trial that we did, but it did grow around the midden and it grew 7 feet tall. And so now I've got an interest in biology that I wouldn't have had if I hadn't had a field crop of hemp.
And you're not the only one. So pretty much the whole of the hemp industry in the UK failed this year because they were trying to grow in the wrong successional soils. The one that we had been working with, where they'd managed to get the soil carbon levels up to a decent percentage, which has to be above 5%, with a good, close to balanced fungal bacteria ratio, did incredibly well, and we were getting 9-foot tall plants.
Right. So now you're just showing off.
Glyn, I'm sorry, I couldn't help.
Glyn, shall I actually introduce you over email as well, so you've got your contacts?
That would be. I don't mind.
That would
happy
be
to help anyone I can.
Really appreciated. Thank you very much.
I know that Glyn is very busy, but the thing is, I have visited Glyn when his plants were little, and it was mind blowing to see the difference between the biological and the synthetic systems.
Right. Fantastic.
All right.
Anyone?
Thank you very much.
Thank you.
Super. See you guys next week. Thank you.
Take care.
Cheers.